Hello, thank you for joining. We'll be starting in a minute or so. Perfect. So let's start today's webinar. First of all, I would like to thank you for joining us in another in Vector Lab in another Into the Block webinar, in which we cover some of the hottest topics in terms of crypto analytics related to the crypto space. Today, I'm particularly excited because we're gonna unveils one of the new areas that we have been working on that is very intertwined, it's very at the intersection of machine learning and crypto assets, and is how can we leverage cutting edge machine learning to understand the behavior of crypto exchanges. So we're gonna be covering a lot of ground, a lot of content, and hopefully will be very, very entertaining. And you're gonna find some of the content that we're gonna share pretty fascinating. A little bit about myself. My name is Jesus Rodriguez. I'm the co-founder and CTO of Intotheblock. We are a platform that specializes in using data science and machine learning to detect, unveil insights around crypto assets, particularly looking at the blockchain level. I have had a long career as a computer scientist with 10 years at Microsoft, building quant systems in Wall Street, exits as an entrepreneur. I'm an active investor and sort of a well-known speaker, author in the space. A couple of logistics data points before we start. At any given point, you can use the Q&A or the chat preferably the Q&A, to ask questions. We have part of the team monitoring the Q&A, and I will stop for questions throughout the webinar. As I said before, Intotheblock as a platform, we focus on trying to leverage and provide fine data insights about crypto assets, particularly looking under the hoods at the blockchain level. And one of the tasks that we set up to work on last quarter was to try to play with different machine learning models that could reveal more insights around crypto exchanges, particularly centralized exchanges. That work is not into the product yet. We have been publishing some content and some articles. So today is sort of the first time that we're openly talking about it in a wider forum, and hopefully you will find it as fascinating as we do, and you will be able to provide meaningful feedback. So what's the agenda? The presentation is divided in two main sections. The first part, I'm going to try to convince you why analyzing crypto exchanges is a machine learning problem and not something that you can tackle with other techniques. Then I'm going to tell you a little bit about how you should think about this problem, right, from the data science perspective, but not a whole lot in depth, and tell you how we did it, right? Reveal a little bit of the techniques that we use. And then the second part is just a lot of gorgeous data visualizations that are going to take you sort of inside the brain of our machine learning models, tell you how our machine learning models are seeing the world of crypto exchanges, what are they envision when they reason through the problem, and we're going to be able to walk through some fascinating visualizations that explain that universe. As I said, at any given point, feel free to stop for questions. So let's start with an obvious statement, right? Centralized exchanges are extremely important to the crypto ecosystem. We all have a love and hate relationship with it. We use exchanges all the time. Give or take, they obviously represent a significant portion of the trading volume. In the top assets, we estimated around 40% of the trading volume, the day trading volume, to come from exchanges. And then if you're able to understand how exchanges move money in and out, you can actually create trading strategies around that, because a transfer into an exchange could be a precursor to a large position and things like that. So from a trading, from a research standpoint, centralized exchanges is one of the components that people would like to understand. But the problem is that centralized exchange today, 10 years after of the Bitcoin white paper, centralized exchanges remain a black box for most of us. If I ask any of you, how does Kraken or Bitstamp or Coinbase work internally, probably you're not going to be able to give me a very sophisticated answer, because a lot of that behavior is not reflected in the blockchain, is hidden behind their own architecture. So a lot of the trades that happen within an exchange are not always recorded in public blockchains, or sometimes are recorded in certain formats, in aggregations, in fragmentation, so in all sorts of mechanisms that make it hard to analyze. We all know that there have been reports that a lot of the volume reported by some exchanges, not the good ones, but for some exchanges, is not real. So volume manipulation is a huge problem. The fact that we don't know which wallets belong to exchanges or not, it also makes it extremely hard. And these patterns that I mentioned, that some exchanges just compose many transactions into one and publish it to the blockchain as a single transaction. So it's really, really hard to extrapolate meaningful intelligence from those patterns. So when you think about crypto exchanges, I mean, there is a lot to consider, but there are 4 components, 4 concepts that I would like to introduce you to. So the hot wallet, that is the one that most people are familiar with, right? The hot wallet is the main interaction point between external parties and an exchange. When you wire money into an exchange, typically goes, at some point in that transfer, goes into a hot wallet. The opposite of that is the cold wallet, that is typically used for a more secure, stable storage that doesn't see a lot of activity. And then on the edges of that, we have deposit addresses that are being used to transfer money into the exchange, right, into the hot wallet, and withdrawal addresses that are addresses that are used to withdraw money from the hot wallet into other addresses, in this case, the withdrawal addresses. So understanding a crypto exchange is understanding those 4 concepts. If you can visualize what's the behavior of a hot wallet, a cold wallet, deposit addresses, and withdrawal addresses, you have a very good chance at understanding the behavior of a crypto exchange, because those are the 4 fundamental components. Now, when you think about analyzing how exchanges behave, this is a machine learning problem. It's not it's not a problem that you solve with hard-coded rules. It's not even a problem that you can even reason through it very clearly, because it's based on nonlinear correlations between many parameters. So this is the type of problem that is very well designed for models that can learn from some behavior and can find new exchanges that match that behavior. So how does that work? I mean, I'm not going to give you a machine learning super course, but in a very conceptual level, imagine that you're looking at a blockchain data set. You have a machine learning model that can learn from that, and it can tell you certain addresses where it belong to an exchange or not. I mean, that's sort of the super high level conceptual view. But this problem could be tackled in almost infinite ways, right? So this is the type of problem that in machine learning could have infinite type of solutions. There's some that are very classic that if you read some of the research papers out there that have been trying to attack this problem for money laundering and tackling fraudulent transactions and things like that, some of the techniques are the same. So for instance, the simplest method is what we call clustering. That is, imagine that you're looking at a population of addresses in a blockchain, and the algorithm will say, look at this, and just based on the pattern, identify meaningful groups that are similar, and by statistically speaking, one of those groups is going to be exchanges. So essentially, you're saying, without knowing anything, just go out there and tell me which addresses look like an exchange. And this is a model that is relatively easy to implement because it's what is called unsupervised learning. It doesn't require a lot of training. It's just not particularly effective when it comes to understand deposit addresses, withdrawal addresses, and all sorts of the most sophisticated questions. Remember, if you have questions, please use the Q&A. We're monitoring, and I'll be happy to stop throughout the session to answer questions. So clustering is one way to think about this problem. Another is what is called classification, in which I'm going to give you an address, and you just tell me the likelihood that this is an exchange or not. Right, and the way this works is you train a model with certain addresses that are exchanges, and then you go and give a new address to say, is it an exchange or not? That's a problem that the model is trying to solve. It learns certain characteristics of the data set, and it tries to infer whether new data behaves like an exchange or not. And then a similar, so the output of a classification model is discrete. Is an exchange or not, 0 or 1? If you want something more like a probability, like what's the likelihood of that this address is an exchange, you're in another side of the spectrum that is what is called regression. So in the case of classification, you're dealing with continuous outputs. In the case of regression, you're dealing with, I'm sorry, in the case of classification, you're dealing with discrete outputs. In the case of classifications, you're dealing with continuous outputs. And that sort of, those are some of the classic, this is very old machine learning techniques, but that they're very applied to try to understand, particularly the firms that are trying to do anti-money laundering, fighting fraud in crypto. They use a lot of these techniques. But what if we could use many models? What if we don't need to pick one technique? What if we could combine many of them? So there is a theory in machine learning called ensemble learning that is a little bit more modern, not super new, but it's, you know, it's not 40 years old, in which essentially we combine many models into a master model, and those models will behave differently depending on different environments. The thesis is that the aggregate of all the models will outperform the best of the models in the long run. So that's sort of the theories. One of my mentors in the space always said this phrase that has stuck with me for years, that said, all models are run in the long term, some are useful in the short term. So just assume that anything you build in machine learning eventually is going to stop working, right? And how do you adapt to that? The data sets change. There is a fork on the blockchain. There is a behaviors that you haven't seen. So if you have many models as one, you can adapt to different environments, and eventually, over time, the performance of the ensemble of models surpass the performance of the best of models. And that's a theory that has proven to be very effective for very mission-critical applications. So what did we do? What did Intotheblock did to tackle this problem? I'm not going to walk you through the entire solution because we're going to be here for 3 hours, but thinking about it at a high level, we decided to create an ensemble of models that could help us classify whether an address was an exchange or not. So we started, this is a little bit of the cycle. We started by looking at the Ethereum blockchain, because in the case of Ethereum, in the Ethereum blockchain is arguably the only blockchain in which we have labeled data sets of exchanges. So the data in other blockchains like Bitcoin, like Litecoin, is very scarce, and it's really hard to find, and it's outdated. But in the case of Ethereum, there are very good high quality data sets that we could use. So we started with that and extracted a large population of features, of attributes that could help us predict whether something was an exchange or not. And then we created a ton of different machine learning models that will tackle some regression, some trees, some combination of things that could help us predict or classify where an address was an exchange. Then we trained that model in the Ethereum blockchain, and then we did predictions on that and evaluated the performance and optimized it and figured out that the performance was very, very good. And here came the trick. Then we needed to optimize the model to be able to, the knowledge that it acquired on the Ethereum blockchain, generalize it to other blockchains, which was fascinating. I mean, when the team told me they were thinking about doing that, I thought that's crazy, it's impossible. And it actually worked. I mean, to the extent that we have been able to to test it, of course. A lot of this is work in progress. So we generalized and assembled the model acquired knowledge, and it was able to go into the Bitcoin blockchain and apply that knowledge. Then we tested and predicted in non-Ethereum blockchains like Bitcoin, like Litecoin and others. And then we added some specific heuristics, some more like hard-coded rules for some edge cases that we needed to optimize. That is not about what the model will learn, but some cutting-edge optimizations for some very, very specific scenarios. And then we optimize, and then we do that again, right? And machine learning is a cycle that never ends, right? The minute you think you have something, you need to start training again and re-optimizing. So it's a cycle. The model is supposed to get better and better and better over time. I hope that makes sense. I think this is sometimes it's a little bit hard to follow, but I hope at a conceptual level from a machine learning perspective, that makes sense. So let me show you. Now we're going to the second part of the presentation in which I'm going to show you what we learned, what our models learned. Think about you're getting inside the brain of the machine learning agent. It's not quite like that because this is actually a visualizer that we created to try to understand some of the predictions that the model was outputting. One of the challenges that you have in trying to tackle this problem with machine learning is that there is no data. So if you're trying to solve this for Litecoin or Bitcoin, there are no data sets of label addresses there's some, but they're very outdated and very small. So from the machine learning perspective, you're flying blind. You're creating something that is giving you outputs, and you don't know if those outputs are correct. That's what I call is the quickest path to get your data science team angry with you. Is horrible because they're creating things that they cannot validate. So how do we validate it? We created visualizations of those outputs that could help us understand if what the model was reasoning, what the model was saying, the path to arrive to that conclusion was correct. And we were able to optimize from that. So it's a combination of machine learning and cutting edge data visualizations. So let me show you a few things here. So how does an exchange look internally? So remember that we talk about 4 components: hot wallets, cold wallets, deposit addresses, withdrawal addresses. Looking at an exchange, how does that look? This is a visualization of how our models thinks about an exchange. Think about, so the green circles are hot wallets. I'm gonna grab the pointer here to show you a few. For instance, the withdrawal addresses that are the oranges, you can see the clusters of orange that are the withdrawal addresses. The deposit addresses that are blue these are the clusters. And then transactions are light blue, so you're seeing many transactions into a withdrawal like that, many deposits into transactions, many transactions into withdrawals. So this is how our machine learning model tries to think about an exchange. Now, let's look at a specific use cases because that visualization that I show you, you cannot do anything with it. So here's some of the things that we learn. So when people transfer money into an exchange, if it's not one transfer to the hot wallet immediately, what the techniques that the exchange use is to combine many deposit addresses into single transactions into a hot wallet. So by the way, let me stop for a second. There is a question asking if there is going to be a recording. Yes, absolutely. We always post the recordings on the webinar into intotheblock.com, and on our YouTube channel, you can find the recording of all our webinars. So what I was saying, imagine that you do a transfer to a hot wallet. How we think about it is from one address to the hot wallet, but what really happens is exchanges combine many of those deposit addresses into a single transaction going into a hot wallet. So this is an exchange that doesn't have a huge volume of traffic, but look at this. So we have many deposit addresses into one transaction going into the hot wallet, and from there into the cold wallet and things like that. So how does this picture look for someone like Binance, an exchange with a ton of traffic? It's the same, but look at this difference, right? We have hundreds of deposit addresses combine into one transaction going into the hot wallet. And you can see that this spider web becomes almost impossible to analyze. We have tons of deposit addresses combined into one transaction that is light blue going into the hot wallet. If you look at the right here, this is the output of our classifier. I tell them, look, the green circle is a hot wallet with 90 to 100% certainty. Deposit addresses are blue. The black is cold wallet, and this is our model is reasoning about that. Taze, that always have smart questions in our webinars, is asking, on the previous visualization, you have big orange clusters. What are those? Let's go to that. So these orange clusters, and we're going to go into the details, are withdrawal addresses. Look at here, it's withdrawal addresses, and these are clusters of withdrawal addresses. Money going out of the cold wallet into a transaction distributed to a bunch of different withdrawal addresses. But just hang tight that we're gonna get into that right now. So we looked at how deposits go into a hot wallet. How about when we transfer funds out of the exchange? How does our models think about that? How does that happen? So exchanges don't transfer one-on-one. Typically, they use the same pattern: one transaction, too many withdrawal addresses. So how does that look? Oh, I'm sorry. I went to slide 5. So this is another content that deals. This is another pattern that we learned that deals with funds being transferred from deposit addresses that follow different patterns, and we're going to follow two specific patterns that are very unique. One is many deposit addresses to one transaction into the hot wallet. This is a pattern that is being followed by many exchanges. And then there is another one that we discover in some exchanges, like Binance, for instance, in which the transfers do not go into the hot wallet directly, but they go into a temporary address. So look at the deposit addresses, group as a transaction, but instead of going to the hot wallet, they go into a temporary address. And that's a pattern that is very common in exchanges like Binance. And if you're following this, if you're a trader and you're looking at, for instance, accumulation in deposit addresses, you can probably look at those temporary addresses because that's signaling a big transfer into the exchange, which could be the precursor to a big position in a given asset. So now, finally, we're gonna get into the withdrawal addresses. I skipped a section ahead. So we also discover that that there are different patterns for withdrawal addresses. So the same way that there are different patterns for deposit addresses, there are different patterns for withdrawal addresses. So in the case of, for instance, this is an exchange with not a whole lot of volume, and this is how it looks like. You have the hot wallet, there are transactions, and those transactions are disperse the fund into one or two withdrawal addresses. Very trivial. Now, how does that look in an exchange with a ton of volume? That is sort of the example that Taze was alluding to. This is sort of a zoom into that picture. We have the hot wallet that is doing it in a single transaction, is just dispersing the funds across a ton of different withdrawal addresses. These are patterns that are followed by exchanges like Coinbase and Binance that have a ton of traffic, and they, in a single transaction, they distribute the funds to a very large number of withdrawal addresses. And again, this, we don't have any insight into this. This is our machine learning model learning. So it classifying orange as withdrawal addresses, green as deposit addresses, and the light blues are transactions. I'm gonna take, before I keep going, I'm gonna answer a few questions because there are quite a few. They're saying, Anonymous is asking if those graphs are from the Ethereum blockchain. This is actually from the Bitcoin blockchain. This is our model applying the knowledge that it acquired in the Ethereum blockchain to the Bitcoin blockchain. George is asking, are you using GraphDP for visualization, and can that visualization capture knowledge into create a semantic representation to make inferences? So the tool that the visualizations are showing is a tool that we created internally, uses different visualization techniques. Yes, so if you wait until the end of the presentation, I'm gonna show you a few things that we're doing to use this information into more sort of inference rules and signals that can be used for something more actionable. Then there is another question: what type of data do you use for generalizing the machine learning models, and where did we source the data from? So we source data from many different places. In the case of Ethereum, from different websites that we're labeling Ethereum addresses like Etherscan and others. Now, when I refer to generalization, essentially what that means is that none of the features that the model learns could be specific to Ethereum. For instance, one of the features could be the time of existence of a wallet, right? If the wallet has been there for a year with other parameters, that has a weight into classifying that wallet as an exchange. Now, instead of the time of existence, we do the time of existence relative to the time of existence of the blockchain, and that way we can generalize the knowledge, that feature for other blockchains. Another question is, what features do you use to train the models? A lot, like over 30. So plenty, from the volume to the types of tokens to the number of tokens, from the time of existence, from a lot. Like it's a very big feature set. I'm gonna keep answering questions as I go along, but let me continue with the presentation. One of the challenges that drives everybody crazy when it comes to analyzing, getting intelligence from blockchains like Bitcoin or Litecoin or Bitcoin Cash is UTXO. So unexpended transactions output is this concept in which transactions could have changed. Those changes get deposited back in the addresses, and they get composed into new transactions. And then to get the accountability right for this type of blockchains is extremely difficult. So what do? We train our model to also identify co-spends, right? The pink circles, which are UTXOs transactions. In this case, we're seeing a transaction going from the hot wallet that is taken as an input that is already a UTXO, and is distributing the output to a number of withdrawal address and to other UTXOs like this one, which can be used for other transactions. That way, our models already know what transfer, when we see that a transfer in the blockchain, what's the likelihood that transfer is a co-spend, is the output of a UTXO transaction. There is a question, anonymous. What does the size of the circle means? Is the size of the transaction in this visualization? But again, this is a lot for what we use internally. So let's think about how this looks like for some well-known exchanges. So I gave you some generic examples, right? How these patterns reflect in the blockchain in general, how our models understand the world inside the blockchain. But let's look at one of the fascinating things that we were able to do is to actually understand how specific exchanges work. So for instance, one pattern are exchanges with a hot wallet, and this is the case of Binance, right? So we determine Binance as a single wallet that is receiving all the deposits from deposit addresses, and it's also the source, so the first stop for the withdrawal onto withdrawal addresses. So everything around is like the quarterback of Binance. Anything around the Binance exchange goes through that main hot wallet. There's other addresses that sort of behave similar to hot wallet, but in general, it follows that pattern of a single hot wallet architecture. But that's not the pattern that all exchanges follow. There are other exchanges like Poloniex in which it uses a dual hot wallet architecture in which the deposits here go into the hot wallet that also transfer to another hot wallet that is the one that is being used for the withdrawals. And that's another architecture that is also used by Bitstamp. It's a similar architecture with a dual hot wallet. The fascinating things that we discovered about Bitstamp is that also transfers a lot of, very recurrently, it transfers a lot of funds from other hot wallets, from other exchanges. So why we have some hypotheses, but this is something that happens a lot from other hot wallets being transferred into the Bitstamp hot wallet. Remember, none of this is exact. These are models making inference over data. So chances are that some of the assumptions sometimes are not 100% correct. So one interesting thing is, what do you do with this information, right? As a researcher, as a trader, what do you do? And there's plenty of fascinating things that you can do. Imagine that I can actually monitor hot wallets and I can see the inflows and try to do an analysis whether certain inflow is a precursor to a specific position or certain outflow is a sign of people realizing gains and getting out of a specific trade. That pattern we can also analyze by seeing the activity around the deposit addresses of an exchange. So there is a lot of interesting things that there is a question, what is the Bitstamp hot wallet hypothesis? I would like to save that one because I don't want to speculate about behavior of an exchange that we don't really have inside information. But to give you a pattern that is not crazy to think about, I'm not saying this is a case of Bitstamp. For liquidity purposes, many exchanges might be borrowing funds from other exchanges. It's as simple as that. I'm not saying that's a case, but that's a pattern that is not insane to think about. So going back to what do we think about this type of, what can we do with this type of information? There's plenty of signals, plenty of insights that could be derived. One that we like a lot is to monitor inflows and outflows. And this is an analysis in which we monitor the volume of inflows and outflows into an exchange and try to extrapolate patterns of whether that's increasing over time, whether it's a bullish sign, whether that's decreasing over time, whether that's a bearish sign. And you can anticipate a lot of movement in the market from the inflow, from just looking at the movement in between exchanges. Is certainly something that you cannot do in any other asset class, and at least here you have a chance to be able to do that. And like that, like this is probably sort of the maximum expression of a signal, but if you decompose this signal, the inflows and outflow, you can have a million mini signals and just monitoring hot wallets or monitoring the activity in deposit addresses and calculating the momentum over time and things like that. There is all sorts of interesting things that we can extrapolate. So that was the bulk of the presentation. There are challenges with this quite a bit, right? One of them is you need to train this model continuously, and there's no data, right? So we need to train the model a lot of time, and there is not a whole lot of data. Another one that is scary is that exchanges change their architecture, right? Binance had 2 hot wallets, now has 3, or 1 hot wallet now has 2, and you need to adapt to that. And obviously, when you're dealing in blockchains like Monero and Zcash that are designed to obfuscate a lot of this information, you have to do a lot of crazy things. So let me summarize, go to questions, and tell you about our next webinar. So analyzing the behavior of crypto exchanges is a machine learning problem. These are not rules that you create. You need to create models that understand a world in which that starts at the blockchain level. Here, many models are better than one. It's hard to create a model that can solve this type of problem by itself over a long time. The core architecture of exchanges has 4 key components: hot wallet, cold wallet, deposit addresses, and withdrawal addresses. You understand that, you're in a good position. If you can analyze what happened with exchanges, you can derive a lot of interesting insight as a trader, as a researcher, as someone who wants to understand the behavior of a crypto asset. You can anticipate a listing on an exchange. There is all sorts of interesting things that you can do. I'm going to go to questions, but before that, I would like to tell you about our next webinar. That is another fascinating topic that we're tackling, that is about social media analysis. So we think that most of the analysis that has been done out there in terms of sentiment and all that is relatively basic. We took a stab, I'm not saying it's better or anything, but we took a stab at trying to do something deeper that is being actually rolled into the product as we speak. And we would like to share in 3 weeks, we're gonna be sharing a lot of those findings with you, how to analyze topics, tone, sentiment, in order to extrapolate some market impact that at least give you something a little bit more meaningful than what we have today. I would like to go to questions. There is a ton on the chat. In the Binance, Rosario is saying, in the Binance example, it appears that there is not a whole lot of usage to the Co wallet. Is that correct? No, I mean, there is, of course. Remember, what I'm showing you is a snapshot. So it could be that in that day, that few hours of that visualization, there wasn't a lot of activity, but obviously the hot wallets on Binance are being used all the time. What type of data did you use, Mo? Jacobo is asking, what type of data did you use for your generation of the machine learning models, and where did you source the data from? I mentioned that before. It was many sources, from Etherscan to others, and we retrained the models constantly. So it wasn't one source. In the case of Ethereum, Etherscan proven to be extremely helpful. Then Ernesto has a long question. I see the top cluster having a hole in the bottom part. Does that mean anything? Is there a correlation between uniformity on the image and user behavior? No, not necessarily. A lot of the behavior that you're seeing on those visuals is behavior of the exchange, right? It's how it decides to distribute funds out and to ingress funds in. And then it has a second question. Is it okay to take a screenshot of the webinar and share it on Twitter? Yeah, absolutely. And if you just go to my blog, there is a ton of these visuals, and I'm pretty sure our team is going to be publishing the slide deck in the next few hours. George is asking, what algorithms are you using, or graph algorithms? So the current implementation uses many, but one of the ones that we have been showing is a random forest, right? That is an ensemble of multiple tree algorithms and regressions and things like that. So that's one of the ones that we found to be very effective. There is going to be research papers in which we obviously explain the methodology. Simon is oh no, sorry, I escaped. No, yes, Simon. Would you tell us the address of the Bitstamp hot wallet? My understanding of Bitstamp is that they use a single hot wallet. Yeah, I mean, happy to, please send me an email. I'll be happy to tell you the ones that we found. And if you have an insight, I mean, happy to incorporate it into the model. Ernesto, again, you mentioned privacy encryption, obfuscating information. Is there anything that can be done to see this information? In the case of Zcash Monero, it's not the privacy itself, it's all this mechanism in which they create 20 addresses for a single transaction and things like that obfuscate. To be determined what we do with that. So we have some hypotheses, but we need to work on it. And then the second part of the question, how do you analyze information on conjoined wallets on Bitcoin? Wasabi, for example, I don't think that's. I think that follows the same pattern of the obfuscation of many addresses for one. But I need to think about that. But I think that's what I'm telling you is correct. The link to the webinar. How do you label your data? Just the traditional way, right? So we take a training data set, we extract the features, and so we go through a process of labeling up front to train the models, and then we extract the features, and and go from there. Ernesto again is asking about the reiterating the question about conjoin. So I'm not sure. I think it's the same pattern in which there are many addresses associated with single transactions, and it's a form of obfuscation. I'll have to check with the team if we have tackled that scenario in particular. George is asking, is graph algorithms relevant here? Absolutely, yes. Yes, so from many ways, right? So it is a blockchain is the graph is a great representation for blockchains, and in the absence of data, visualizing the transaction graph is very helpful. And some of the algorithms like Dijkstra and all that help you find paths and things like that, extremely relevant. If my life would be tremendously easier if we had all our blockchains in graph databases instead of how we have it today. So yes, absolutely, super helpful. I don't think our team is posting the link to the next webinar. Here's my contact info, jr@intotheblock.com. You can email me through my Medium blog as well, or directly through Intotheblock. I really hope you enjoy the webinar. This is the first time in which we unveil a lot of this work at a larger scale beyond some articles. And if you have any feedback, I'm gonna be sending some notes. Please correspond directly with us. This is like flying blind, so we appreciate any help that we can get. Thank you very much. I'll see you in the next webinar.